Hi, I'm starting a new project for my Maqueen Plus robot, and this time I want to design a battery fuel gauge for my Maqueen Plus robot. And in this stage of the project, I will just describe what my objectives are, the hardware, the software that I'm using. I will show you the results, talk about any issues, and give you my references. So this is all going to be based on a chip called the MAX 17043, and it has the capability of calculating the capacity of a lithium-ion battery, and that's what Maqueen Plus is using as its source of energy. And the interesting thing is it has its own algorithm built in, and there's no need to calibrate or add additional components. And a very interesting thing is that you can set an interrupt in your software for a low battery warning. And I'm going to use that capability in my design for Maqueen Plus to automatically navigate to a battery charging station. So what I have to do is add a microprocessor with an interrupt pin and also a I2C bus so that it can communicate and get the status of the battery. So here are my objectives. I want to verify that the DFRobot lithium battery fuel gauge actually works. And it's the one that's using the MAX 17043 chip. And I want to verify both the hardware and the software. And I won't be using microbit. I wanted to let Maqueen Plus reserve the microbit for critical movements and add an additional or a second computer to Maqueen Plus. And it will be a Arduino computer. So which Arduino computers will work? And that's one of the aims of the project. And finally, I want to design a self-charging system for an autonomous robot. So here's the hardware. I'm going to use the DFRobot Gravity I2C, and it's a lithium battery fuel gauge. And I'll be looking at various Arduino computers, the Micro, the Arduino Nano, the Lotus, and there is actually two Lotus computers from Seed Studio. There's the Lotus based on the AT Mega 328, which is Arduino Uno compatible. And finally, the more powerful Cortex M0 Plus. And of course, I need to add a lithium battery. So it's all going to start off with the DFRobot fuel gauge, connect that to a lithium-ion battery, and the connection to the Seed computer, and here I'm showing the Arduino Nano computer, and the connection is an I2C connection. And I'm also going to house or insert the Arduino Nano on a Grove shield, and that'll give me extra ports. So the way I talk to the robot, I'll show you later. So here's the software for testing. There's a library available. All I have to do is compile it and run it. And I've got it installed now on the Arduino IDE. So here's a little bit about the software. There's defining the type of computer and setting up a interrupt callback. So the interrupt callback just simply sets a flag when the level of the battery, which in this software has been set at 32%. So if the battery level is less than 32%, it sets up an interrupt, and you can then do something with that. And here's the main loop for the program. It just simply goes around every 2 seconds, and it then just prints both the voltage and the remaining capacity in the battery. So here's the result. The printed result here comes from the serial port of the software, and I met all the objectives of the project. And finally, this will be how it couples to Maqueen Plus. So there'll be a serial port, and the UART port on the Arduino Nano will be connected by a converted cable into one of the microbit pins ready to process. So finally, here are my references. All the computers came from Seed Studio, and the fuel gauge from DFRobot. Here is my Maqueen Plus robot, and in the next project I want to add a battery fuel gauge to it. And I'm going to start off with a desktop prototype, which is just over here. And on this desktop prototype, I've got a DFRobot battery fuel gauge, which is here, connected at one side to a lithium-ion battery. And there are two cables that then connect it to a computer. So the first cable is a DFRobot cable, and it then goes into a Grove cable, and eventually it then goes into a Arduino Nano computer with the I2C port. And it's already running the software, and just to show you what's happening, we'll go off to the serial port over here, and you can see that it's measuring the voltage of the battery and the percentage of charge remaining.